Okay, good afternoon. Hope I'm audible and you are also not sleeping after your lunch. Whether all of you had your lunch or not, or you are not getting time, still people are joining. Okay, so I will move ahead. Where were we yesterday? We are looking for the stochastic processes. It has a lot of applications in real life. Many applications are there in biological sciences also, where we are studying what will happen after time t. So financial applications are there, like stock market prices, even prices of oil, prices of all commodities, how they are changing. It changes with respect to time. Okay, so what happens if this is the growth rate? If this is the rate of increase in price, what will happen after certain time? Somebody says कि उसका price इतना होगा after these many days. Somebody says it will come down. Somebody says it will go up. How they are predicting? So stochastic processes are very important in such cases. So yesterday I explained the assumptions which we are making stochastic processes. Once again, I will go through it and we'll move ahead. Hope all of you understood the assumptions. What we are assuming over here, in the small interval of length delta t, probability of happening of one change. It is given by lambda and delta t plus O delta t, where delta t is a small length of interval. Lambda n is rate of change, maybe rate of growth, rate of decay, etc. O delta t is you can say gravity is not exactly equal to lambda and delta t plus something is there. What is that plus something? It is a function of higher orders of delta t. Okay, so it is basically a function of that length of the interval. How that function is? The function is such that when you take limit at delta t tends to 0, मतलब जैसे जैसे तुम वो length of interval कम करते जाओगे, O delta t upon delta t approaches to 0. Such a small interval that delta t is. So probability of there will not be any changes, 1 minus lambda and delta t minus O delta t, and more than one changes O delta t. So in general, what we can say is that length of interval delta t is such a small interval that there may be possible only one change or no change. More than one change probability is very small. It is very small. Okay, fine. So what I will do today is we are going to discuss about the general stochastic process first. And once you understand this, we are going to see the stochastic process. But the basic idea and it is same. Okay. So it is very important to understand what we are going to study today. Okay. So again, the same kind of assumptions you will see in each and every stochastic process. What will be the difference in each that I will let you know at that time point. Okay. So the assumptions are everywhere we are assuming that xt denote the number of changes at time t or in the interval 0 to t. So what has happened till time t or from time interval 0 to t, that is denoted by xt. Why is it a random variable? Because it changes. See, there are two types of models basically, deterministic models and non-deterministic models. Non-deterministic models you can call them as stochastic models also. So in deterministic models, you are getting the exact equations and hence you can predict the things exact. But in stochastic models, for the same set of values, you may get different solutions at different time points. Okay, so here something is non-deterministic. Fine. So what is xt? Xt is a random variable, right? And which is indexed by a parameter say t, and we are referring t as time. Now, we want to obtain the distribution of this xt. So, let us consider that PNT. What is the meaning of PNT? Probability that random variable xt takes value n. That means I may say that probability that there will be n changes at a time t or in the interval 0 to t. Now n changes means what? I have already told you. N changes means n times share of prices may either increase or decrease हो गया होगा. So there are n changes. कहाँ से कहाँ तक? For example, stock market, it starts at say 8:30. What is the scenario at say 1 p.m.? 1 p.m. From 8:30 to 1 p.m. So what is my t in this case? From 0 to t means since it is starting at 8:30, that is my 0th point. And what is the situation at 1? That I am observing. So how many times that changes has occurred in that share price? Let us denote it by n. Okay. So what is the probability that there will be n changes in the price of a share at a time t or during the interval 0 to t? Okay, what can be n? There may not be a single change, n can be 0. There may be a one change, n can be 1. Two changes, three changes, so on. Isn't it? So what are the possible values of n? N takes value from 0, 1 to so on. Right? And what do we mean by finding the probability distribution? We are finding the possible values of the random variable and what is the probability that random variable x takes that particular value. Same thing I'm doing over here also. What is the probability that stochastic variable xt takes value n? And what is it in its interpretation? Probability that n occurrences or n changes in the time interval 0 to t for all n equal to 0, 1 to so on be the PMF of stochastic variable xt. So here onwards, always remember if I say PNT, PNT is nothing but probability distribution of stochastic variable xt. And what is its interpretation? Probability that there are n changes, n arrivals, n departures in the time interval 0 to t. Hope the notation is clear to you. Am I audible?
Yes, ma'am.
Okay, fine. Next, as we discussed yesterday, the next assumption is what will happen in the interval of length delta t. So if n changes have already occurred in 0 to t, then in the interval t to t plus delta t, matlab in the interval of very small length delta t, probability of one change is lambda and delta t plus o delta t, no change 1 minus lambda and delta t minus o delta t, and more than one change is o delta t, where o delta t is function of higher orders of delta t such that limit delta t tends to 0, O delta t upon delta t is equal to 0. So basically these assumptions are common in all the stochastic processes. Okay, but then what will differ? Here will be the difference. The form of lambda n. If it is a arrival process, if it is a birth process, you will find lambda n over here or particular value of lambda n. And when it is a departure process or death process, you will find mu n over here. Generally, arrival or birth rate is given by lambda, and departure or death rate is denoted by mu n. Now, when the process changes, the form of lambda n will change. And because of that, and also initial conditions will change. I will let you know what is the initial condition. For example, initial population size is 0. When you are considering the example of cinema theater, before the cinema actually starts, initial population size in the theater is 0, right? When the time actually comes closer and closer to the actual timing, then it will start. Uh, I mean, people will start coming to the theater and it will get full depending on how the picture is, isn't it? Okay, so initial condition means what is the initial status, whether population size is 0 or it is not equal to 0. Like for cinema theater case, whether population size should be greater than 0, not required. है ना पहले से I mean before अगर 2 o'clock का movie है so maximum people can come by 1:30, isn't it? Not before than that. So anyway, but if I consider at 1:30 also, population size, initial population size is 0. Afterwards, it will get on adding, isn't it? So depending on how much is your initial population size and what is the rate of arrival and rate of departure, our form of PNT changes from process to process. Anyway, we will go into details of it afterwards. But right now, what I'm going to do is here we are considering the general stochastic process, and from it we are going to see how to find the probability distribution of a stochastic process. Okay, remember always the steps are same. Just because of the rate changes and the initial population changes, you are getting the different form of distribution of different processes. Okay, otherwise the steps are same. So always when we are starting with this any kind of stochastic process, first we will write down the assumptions, then we are going to find the probability distribution of n. What is n? N is how many units are there at time t. That is your xt. Okay, what is the probability that random variable xt takes value n? Okay, fine. So now our actual work start. To find the probability distribution of stochastic process, what I am going to consider is consider Pn t plus delta t. Okay, what is its interpretation? What is PNT? Probability that there are n changes at time t or in the interval 0 to t. Now what am I writing? Pn t plus delta t. Now what does it mean? Probability that there will be n changes in the interval 0 to t plus delta t. Are you getting the difference? PNT means n changes from 0 to t. Now I am writing TNT plus delta t means there will be n changes in the interval 0 to t plus delta t, right? Because here now it is, I am looking at the time point t plus delta t. Okay, now I want this particular probability PNT plus delta t. What is the probability that stochastic variable xt takes value small n at a time t plus delta t? Now to find probability of this event, let us divide the interval 0 to t plus delta t into two disjoint sets, 0 to t and t to t plus delta t. Suppose this is your full interval, 0 to t plus delta t. I am interested in finding probability that there will be n changes from 0 to t plus delta t. So to find the probability of this event, what am I doing? I am dividing this whole interval into two disjoint sets. One is 0 to t and second is t to t plus delta t. Okay, fine. So I want total n changes to be there from 0 to t plus delta t. Now what can be the different cases? Let's see. We have to make a table where in the first column we are writing number of changes in 0 to t. In second column, number of changes in t to t plus delta t. And third column, probability. Okay. Now, what I want a total, what is the probability that there will be total n changes from 0 to t plus delta t. Okay. So for that, what am I doing? कि 0 to t में क्या हुआ होगा और t to t plus delta t में क्या होगा, so that I will get total to be n. Okay, I want total to be equal to n. So 0 to t में already n changes हुए होंगे. For example, तो t plus t to t plus delta t टाइम में कितने changes होने चाहिए? 0. Why? Because I want total to be n. Are you getting? Next, 0 to t में n minus 1 changes हुए होंगे. Okay, तो t plus t to t plus delta t में कितने changes होंगे? Only 1. Right? Likewise, और क्या हो सकता है कि 0 to t में already n minus x changes हो गए होंगे. For example, x की values क्या क्या हो सकती है? 2, 3 up to maximum n. मतलब अगर यहाँ पे n minus x, suppose x is 2, 0 to t में already n minus 2 changes हो गए होंगे, तो t to t plus delta t में कितने changes required है? 2. Because total changes we want from 0 to t plus delta t to be equal to n. Try to understand this. This is very, what you can say, fundamental. Because each and every model is dependent on this. How you are listing out the different cases and how you are writing the probability. This is the base. Okay. Is 0 to t plus delta t may, if I, for example, try to understand the example of that share market. If from 8:30 to say 1 o'clock, how many changes are there in the prices of a share? So what I am doing, मुझे ऐसा चाहिए 0 to 130. Okay. So I will consider 0 to say very 1.29 तक क्या हुआ, and 1.29 to 130 is t to t plus delta t. Okay. तो 0 to t मतलब 8:30 to 1.29 तक क्या क्या हो सकता है? n minus 1 changes हो सकते हैं, और नेक्स्ट ये छोटे से इंटरवल ऑफ 1 मिनट में 1 चेंज हो सकता है. ओके, ऑलरेडी 0 टू t तक मतलब 8:30 to 129 तक n चेंजेस हो गए होंगे. यहां से यहां तक 0 ही चेंजेस हुए. और क्या केसेस हो सकते हैं? यहां से यहां तक n-2 चेंजेस हुए हैं, तो यहाँ पे 2 चेंजेस होने चाहिए, बिकॉज आई वांट टोटल टू बी इक्वल टू n. यहां से यहां तक n-3 चेंजेस हुए होंगे, तो यहां से यहां तक आई वांट टू बी 3 चेंजेस. ऐसा हो सकता है क्या? उसकी प्रोबेबिलिटी क्या होगी? दैट आई एम गोइंग टू चेक, सी ओवर हियर. ओके, so all other cases I am listing over here कि n minus x takes value from n to 2 to n. So when n will be n मतलब क्या? 0 to t तक n minus n मतलब 0 changes हुए हैं. Now what is the probability that t to t plus delta t में all n changes होने की? Let's see. Okay. So what I did, I divided the full interval into two parts. क्या हो सकता है? First case. Now consider this first case. First case क्या है? कि I want total changes from 0 to t plus delta t to be equal to n. Now what is the first case? Already 0 to t में n changes हो गए हैं. Now t to t plus delta t में 0 changes. Okay. So probability that there will be n changes from 0 to t plus delta t is equal to probability of already n changes from 0 to t and no change in t to t plus delta t. No change means zero change. Okay. Now let me write the probability. So probability of n changes in 0 to t. How to write that probability? It is nothing but p and t. N changes in 0 to t. That is nothing but my p and t. And probability of 0 changes in t to t plus delta t. Now according to assumption, probability of 0 changes in the interval of length delta t, it is 1 minus lambda and delta t minus O delta t. See here, no change. Right? So this may be the one case. I have listed all the possibilities. क्या क्या हो सकता है? 0 to t plus delta t में I want total to be n. तो I am writing it in terms of 0 to t में क्या हुआ होगा और t to t plus delta t में क्या होगा. Right? So one case we have seen. So either 0 to t में already n changes हो गए होंगे और t to t plus delta t में we want to be 0 changes. दूसरा क्या केस हो सकता है? और 0 to t तक n minus 1 changes हो गए होंगे और t to t plus delta t में 1 change होने की probability. Then total will be again n. Right? So I want n. What is the probability that there will be n minus 1 changes in the interval 0 to t? Its probability is denoted by p n minus 1 t. Probability that there will be n minus 1 changes and in the interval 0 to t. Right? Now multiplied by क्योंकि n minus 1 changes in 0 to t and 1 change in t to t plus delta t. Right? And so multiplication. Right? What is the probability that there will be one change? There will be one change in the interval of length delta t. We have listed it over here. Lambda and delta t plus O delta t. Sorry. Okay. Now here I did not write lambda n delta t. I wrote it as a lambda n minus 1 delta t. Okay. What is lambda? It rate of change in the population when population size is n. Okay. तो अभी यहाँ population size कितनी है? n minus 1. 0 to कितने changes हो गए हैं? n minus 1. Right? So my rate of change is dependent on, that is what is the meaning of that index n. That's arrival rate, that departure rate, that is dependent on current population size. What is the current population size? After changes to n minus 1. So here your lambda is also lambda to the suffix n minus 1. Okay. Lambda n minus 1 delta t plus O delta t. So these are the two cases. Now what will be the third case? I have taken all of the remaining into one only. Why is it so? What are the chances that there more than one changes in the interval of length delta t, the probability is very less, which is O delta t. वो 2 changes हो या 3 changes हो या n changes हो, if it is more than 1, its probability is very less, which is O delta t. Hence, I have put all of them together. So what is the probability that there will be n minus x changes in the interval of length t, and afterwards there will be x changes in the interval of length delta t. It is denoted by probability that there will be n minus x changes in the interval of length 0 to t. It is nothing but p n minus x t, right? Multiplied by, there will be x changes in the interval of length delta t. Now what is x? X is more than 1. So you by third assumption, it is only, right? See here. More than one change की probability is given by O delta. Is it okay? Is the table clear to you? If there is any doubt, please ask me, because this is very basic, and in each and every stochastic process we are going to use this particular table. Afterwards only we are starting. So everywhere in every process you will see this table. If anybody has any doubt, please ask me. Okay. So now what I want to find basically the P n t plus delta t. What is the probability that there will be n changes from 0 to t plus delta t? Now, what will happen? This will happen. Already yeah, or this case will happen. मतलब यहाँ पे n minus 1 cases हुए और यहाँ पे 1 होगा, या फिर यहाँ पे थर्ड केसेस, यहाँ पे n माइनस एक्स केसेस हुए हैं और यहाँ पे x चेंजेस होंगे, right? So either this will happen or this will happen or this will happen, right? So this or this or this means we will add these probabilities. Right? We will add these probabilities because this or this or this. So my P and T plus delta T is addition of these three probabilities. Now I have solved the bracket. So P, what will be the addition? P and T into this one. It will be P and T again. Right? So I wrote it over here. Second term, minus lambda and delta t into p3, which is over here, minus n lambda and delta t, p and t. Next, I have not mentioned this term right now. Okay, I am mentioning all the terms of O delta t at the end. Here, lambda n minus 1 delta t into p n minus 1 t. Now, which are the terms remaining? Here is a term of O delta t into p and t plus O delta t into p n minus 1 t plus p n minus x t. O delta t is there, right? But all those three, for all those three terms, I have written O delta t and addition or subtraction of them. For all the terms of O delta t, you just write O delta t once. That is sufficient. Even if you write it again and again, there is no problem, no harm. But that will increase our work, because anyway, the terms which are containing O delta T term, that are going to be 0. Okay, so I have written this term of O delta T only once. Okay, now what is the next step? Divide both sides of this particular equation by delta T and take the limit as delta T tends to 0. Okay, so see here. What I did is I took this PNT term to this side. So PNT plus delta T minus PNT. Okay. Now what am I doing? Divide both sides by delta T. So divided by delta T and take limit as delta T tends to 0. Okay. Is equal to. Now look at this term, this side. See here in this term delta T is there, right? Since I am dividing each term by delta T, this will get cancelled and what will remain is minus lambda n PNT. You can see over here, minus lambda n PNT. Again, in the next term, again delta T is there. So after dividing by delta T, this delta T will get cancelled and what will remain is again lambda n minus 1 Pn minus 1t. See here, lambda n minus 1 Pn minus 1t. So since there is now no term of delta T in these two terms, there is no question of taking limit as it is constant with respect to delta T, these two terms. And now which is the remaining term? Term is O delta T. And so divide it also by delta T, O delta T upon delta T and take the limit as delta T tends to 0. Okay. Now look at the first term over here. F of x plus h minus f of x upon h. Limit h tends to 0. What it is? F dash of x. Similarly here, Pnt plus delta t minus Pnt upon delta t, limit delta t and tends to 0. What it is? By definition of derivative in terms of limit, it is Pn dash t. Right? It is equal to what? This is constant with respect to limit. This is also constant with respect to limit. Plus, what is the limit delta t tends to 0, delta t upon delta t? It is 0. Right? Because of the assumption. How the function O delta t is? It is like this. So, I have listed separately the terms of O delta t. Hope you are getting it. Okay. So Pn dash t plus lambda n Pnt is equal to lambda n minus 1 Pn minus 1 t. Call it as equation number 1, which is the first differential equation for general stochastic process. You know what are the differential equations. Is it okay? Now I will consider the second case. Probability of there will be 0 changes at a time t plus delta t. So again, consider the interval from 0 to t plus delta t as 0 to t and t to t plus delta t. So probability of 0 changes in the interval 0 to t plus delta t is equal to probability of 0 changes from 830 to 130 matlab there will not be any change till 129 and also there will not be any change from 129 to 130, isn't it? So it is same as probability of 0 changes in 0 to t and no change in t to t plus delta t. Right? 129 तक भी शेयर की प्राइस नहीं बदली और 129 to 130 में भी चेंज नहीं हुआ. So then only there will be total 0 changes in the share price, isn't it? So What will be this probability? Probability of zero changes in 0 to t. It is P0t, isn't it? And no change in t to t plus delta t. Now, by assumption 2, no change means 1 minus lambda and delta t minus O delta t. But now, what is my n? N is 0. See, P0t. So, lambda 0 delta t. Are you getting? Now divide both sides by delta t and again take the limit as delta t tends to 0. What will happen? Again, this will be first term on RHS will be P0t. I am taking it to the LHS. So P0t plus delta t minus this P0t upon delta t, take limit as delta t tends to 0 is equal to, the first term here will be lambda 0 into P0t into delta t, right? So delta t will get cancelled and what will remain is only minus lambda 0 P0t minus limit delta t tends to 0 or delta t upon delta t. Okay, again, this term will be P0 dash t plus this second term as it is lambda 0 P0t is equal to, this will be 0, right? Limit delta t tends to 0 or delta t upon delta t. Call it as equation number 2. Now, this is the second differential equation for general stochastic process. Why I am calling it as general stochastic process? Because I am talking about the changes. Changes can be positive, can be negative. And in general, I am assuming that rate of change is equal to lambda n. Now maybe we are going to see the particular cases of stochastic process. Okay, so here I have made a remark that if the form of lambda n, that means rate of change kaisa hai, is given and initial condition is known, we can solve the differential equations and we can obtain the form of P and T. Is it okay? अगर rate of change is given to you and initial condition कि share की initial price क्या है when stock has opened today, that is known to you, we can obtain the probability distribution of there will be n changes at a time 3. Probability distribution of xt. Okay, so this is about the general stochastic process. Now, what we are going to study in stochastic processes are different particular cases of stochastic processes. Poisson process, which is very popular, birth process, death process, birth and death process. Okay. So, you can see this is a flow chart, not exactly flow chart, I can call it as a diagram, which shows that general stochastic process is divided into 4 different types: Poisson process, birth process, death process, birth and death process. In Poisson process, rate of change lambda n is equal to lambda. The rate of change is independent of current population size. Current population size could be rate of change is always constant. And here initial population size is 0. Birth process में हम क्या consider करने वाले हैं? Again, pure birth process and Euler's birth process. Pure birth process में again we are considering the pure birth process where initial population size is 0 and initial population size is some number say A. Euler's birth process में we are going to consider lambda n, that is rate of change is proportional to n, and so lambda n is equal to n lambda. तुम्हारा रेट ऑफ चेंज कितना है? अभी तुम्हारा पॉपुलेशन साइज या सिस्टम में जितने भी ऑब्जेक्ट्स है मल्टीप्लाइड बाय रेट ऑफ चेंज. Next, what are we going to do is we are going to study death process. In that again, pure death process and Euler's death process. Pure death process में क्या होता है? Rate of decay, rate of death, rate of departure is independent of population size. So mu n is equal to mu. Euler's death process में mu n is equal to n mu. वैसे ही लास्ट इज बर्थ एंड डेथ प्रोसेस, जहां पे दोनों भी अलाउड है. दैट इज यू कैन कंसीडर पॉपुलेशन ऑफ एनी लिविंग ऑर्गेनिजम्स. सो हियर नॉट ओनली लिविंग, नॉन लिविंग भी कंसीडर किए जा सकते हैं कि जहां पे अराइवल्स एज वेल एज डिपार्चर्स दोनों पॉसिबल है. सो दे इन दैट बर्थ एंड डेथ प्रोसेस वी आर गोइंग टू स्टडी a particular case of it, which is linear growth model. Is it okay? So, what are we going to do in all these models? Since we know the initial population size and rate of change, we are going to obtain the expression for PNT. What is the probability that there will be n units in the system at time t, or there are n changes in the system at time t? Is it clear? So we will start with one particular process tomorrow. If there is any doubt, you can ask me now. Please ask me if you have any doubt. Are you understanding this concept? Would anybody would like to say something? Today's recording will be saved to Jyoti Jagdale's Google Drive. Jyoti, are you there?